The quest to find life on a planet beyond Earth is intrinsically linked to the search for water in the cosmos, and on other planets. As one of the universe's most abundant molecules, water is vital for all known forms of life, serving as a universal solvent essential for critical biological reactions. This understanding drives astronomers' excitement when they detect signs of water vapor on distant exoplanets. One such intriguing discovery is the planet GJ 9827d. This exoplanet, no larger than twice the size of Earth, may possess a water-rich atmosphere. However, with temperatures soaring to 800 degrees Fahrenheit, similar to Venus, GJ 9827d is far from hospitable. It's a world shrouded in steam rather than a potential home for life as we know it. A recent observation by NASA's Hubble Space Telescope marks a significant milestone in exoplanet research. Hubble detected water vapor in the atmosphere of GJ 9827d, the smallest exoplanet where such a discovery has been made. This finding nudges us closer to identifying planets with environments akin to Earth. This would be the first time that we can directly show through an atmospheric detection that these planets with water-rich atmospheres can actually exist around other stars, said team member Bjorn Bennick of the Trottier Institute for Research on Exoplanets at Université de Montréal. This is an important step toward determining the prevalence and diversity of atmospheres on rocky planets. Laura Kriedberg of the Max Planck Institute for Astronomy in Heidelberg, Germany, adds to the enthusiasm. Water on a planet this small is a landmark discovery. It pushes closer than ever to characterizing truly Earth-like worlds, Kriedberg said. The Hubble observations, spearheaded by Ian Crossfield of Kansas University, aimed to not only detect atmospheric molecules but specifically to search for water vapor. Whether the detected water vapor is a dominant component or a minor element in a hydrogen-rich atmosphere, the finding is very significant. Until now, we had not been able to directly detect the atmosphere of such a small planet. And we're slowly getting in this regime now, added Bennick. At some point, as we study smaller planets, there must be a transition where there's no more hydrogen on these small worlds, and they have atmospheres more like Venus, which is dominated by carbon dioxide. Two main theories emerge regarding GJ 9827d's atmosphere. It could be a mini-Neptune, retaining a hydrogen-rich atmosphere interspersed with water, or a larger version of Jupiter's moon Europa, which harbors vast water reserves beneath its crust. The planet GJ 9827d could be half water, half rock. And there would be a lot of water vapor on top of some smaller rocky body, said Bennick. If the planet has maintained a water-rich atmosphere, it likely formed farther from its star, where ice was abundant, before migrating to its current, warmer location. Alternatively, it may have originated near its hot star, with only traces of water in its atmosphere. The Hubble study involved monitoring the planet across 11 transits over 3 years. These transits, where the planet passed in front of its star, allowed Hubble to detect the spectral signature of water molecules in the atmosphere. Crucially, any clouds on the planet are low enough not to obstruct Hubble's view, enabling the detection of water vapor above them. Observing water is a gateway to finding other things, said Thomas Green, astrophysicist at NASA's Ames Research Center in California's Silicon Valley. This Hubble discovery opens the door to future study of these types of planets by the James Webb Space Telescope. JWST can see much more with additional infrared observations, including carbon-bearing molecules like carbon monoxide, carbon dioxide, and methane. Once we get a total inventory of a planet's elements, we can compare those to the star it orbits and understand how it was formed, Green concluded. GJ 9827d in the exoplanet Pantheon, originally discovered by NASA's Kepler Space Telescope in 2017, GJ 9827d orbits a red dwarf star, GJ 9827, located 97 light-years away in the constellation Pisces, completing an orbit every 6.2 days. This distant world, while not a candidate for life as we know it, provides invaluable insights into the diversity and nature of exoplanetary atmospheres, inching us closer to understanding the complexities of our universe. In summary, the discovery of water vapor on the exoplanet GJ 9827d by NASA's Hubble is a monumental step forward in our understanding of the universe. While the harsh, steamy conditions on this planet make it inhospitable to life as we know it, this finding opens new doors in the study of exoplanetary atmospheres, particularly those resembling Earth's. It challenges and expands our knowledge of where and how planets with water-rich environments can exist. As we continue to explore these distant worlds, each discovery like GJ 9827d brings us closer to answering the age-old question of whether we are alone in the universe and deepens our understanding of the diverse planetary systems that exist in the cosmos.